Hi guys, here is MIH. After conducting many experiments involving high-temperature gases like the catalytic oxidation of ammonia and sulfur dioxide, as well as the more recent ketene lamp, I realized that a tube furnace capable of heating the gas flow at a sufficiently high temperature is really useful, so I decided to make one myself. The product is very simple and unrefined, but it worked surprisingly well and easily reached a temperature of more than 1000 degrees C, with much room going further. The core element of the tube furnace is, well, a tube. For most furnaces in laboratories, a quartz glass tube is used due to its high melting point, transparency, and resistance to oxidation. I am also going to use a quartz tube, but I know that the cost of quartz glass can be quite prohibitive. Hence, alternatives such as high alumina heat-resistant tubes and even steel tubes can be used, as long as they're compatible with your intended use. More specifically, I'm using a quartz tube with two 2429 ground glass joints because I plan to use the furnace as a part of my sulfur dioxide catalytic oxidation project, and I have to use an all-glass apparatus to withstand the sulfur trioxide forming in the process. But for most generic use, a plain tube without joints would be perfectly fine. And yes, tubes with ground glass joints are much more expensive than tubes without them, and my tube here costs 70 RMB or $10. An electric heating wire will then be wound on the tube. I originally used a 0.5mm nichrome wire and tried to wound it at a roughly equidistant pattern, but it was really difficult to get every spacing roughly equal so that no hot spots or even short circuits will appear. I then tried to use an 1200 watt heating wire made from iron chromium aluminum alloy, which is a much cheaper and slightly more heat resistant material than nichrome, so it suits with my use more. I stretched the wire to 4 times its original length and wound it around the tube tightly using 2 rings made from thick copper cable to secure the ends. Be careful to not break the quartz tube in this step, as the heating wire is very elastic and may spring out of control, requiring a large force to hold it in position that might crack the tube. After successfully taming the heating wire, let's test if the furnace would work without adding insulation. I set the quartz tube on a testing stand and placed a K-type thermocouple probe in it that can record temperatures of up to 1400 degrees C. I attached the two ends of the wire to a socket that plugs into a variable resistor so that I can adjust the heating levels of the tube. The variable resistor is initially turned to 80% power, and the temperature rapidly rises to around 409 degrees C. The final stabilizing temperature at 100% power was 550 C, which gave me the confidence that the furnace can reach a very high temperature if enough insulation is added. I added 2 layers of aluminum silicate insulating wool around the tube, each with a thickness of around 1.5 centimeters. Many tube furnaces use much more insulation than here, but I only have this much wool left, and as you'll see in a minute, this insulation is truly more than enough. I cranked the resistor to 60% power and waited for 10 minutes, after which the temperature rose to 800 degrees C. A dull red color is seen in the quartz tube, and apart from that, the heating wire and insulation wool seems to work perfectly. To my surprise, the temperature kept rising and reached 1000 degrees C only after 2 minutes. Now, the interior of the quartz tube is glowing a warm and beautiful orange color, and the iron rod of the test stand is also red hot. At last, the temperature stabilized at 1080 degrees C, and the head of the thermocouple is also glowing orange. After 30 minutes of testing, I turned off the current to let the furnace cool and test its insulating properties. It seems that the tube cooled rather slowly and maintained its heat well. I lifted the insulation wool and inspected the heating wires in the quartz tube. The wires appear perfectly fine and evenly oxidized, the tube has no visible cracks, and the oxide layers on the 2 copper rings have flaked off. Nothing too bad. I think I can say that now I have a brilliant tube furnace that works nicely. But above all, I really can't believe this very high temperature of nearly 1100 degrees C is reached just by using 60% of the furnace's full power and only 2 blankets of insulating wool. Imagine what would happen if I turned the power to 100%. Well, the lifespan of the heating wire will definitely be shortened, but I believe a maximum temperature of 1400 degrees C or even higher can be achieved, probably enough to even soften the quartz tube. This furnace will appear in my next video on the 3rd trial of the ketene lamp. See you soon.